EPSEA nitrogen generation, a widely used gas separation method. Using carbon molecular sieve as adsorbent, leveraging oxygen, nitrogen molecular diffusion rates in adsorption towers, adsorbing oxygen to obtain nitrogen. When cleaning dry compressed air contacts carbon molecular sieve, based on diverse molecular diameters, differential adsorption of gas molecules by carbon molecular sieve at pressure ranges of 6 to 8 bar. Carbon molecular sieve adsorbs oxygen, moisture, carbon dioxide in compressed air, excludes nitrogen due to larger molecular diameters. Nitrogen passes through particle gaps to achieve high purity. When pressurization is rapidly released to atmosphere, oxygen and carbon dioxide are desorbed and released to atmosphere. Widespread applications of nitrogen generators in various industries. The nitrogen purity can be adjusted from 95% minus 99.999% to meet the different requirements. How does a nitrogen generator work? Brief guide to nitrogen generator parts before operation flow. First, compressed air with particulates, water, and oil entering pipelines from outlets. Then pass through grade C filter. Remove solid particles larger than 3 micrometers and reduce the oil mist content to 5 ppm. Automatic drain removes filter accumulated liquid oil and condensed water. Refrigerated air dryers condenses water vapor to liquids by further cooling. Discharged out of system via a water separator and drain. Compressed air is now highly dry and the PDP reaches to till 10C. Then enter the grade T filter. Remove solid particles larger than 1 micrometer and reduce the oil mist content to 1 ppm. Finally, enter the grade F filter. Remove solid particles larger than 0.01 micrometers and reduce the oil mist content to 0.01 ppm. The compressed air reaches a clean and dry state and enters the dry air buffer tank. Next is the nitrogen generator operation flow. First, tower adsorption and tower B desorption. Clean and dry compressed air fills tower up from bottom to top. Carbon molecular sieve in tower adsorbs air molecules except nitrogen. Finished nitrogen stored in nitrogen buffer tank. Using part of finished nitrogen to purge and desorb tower B. Desorb air vents to atmosphere via muffler. Pressure equalization between tower A and tower B after about 50 seconds. Recover part of finished nitrogen. Subsequent state switching between tower A and tower B for cycle operation. Under action of purity control module. Qualified purity nitrogen automatically output to user end via meter settings. Unqualified purity nitrogen vents to atmosphere. The nitrogen in this system has a PDP ranging from minus 30C to minus 40C. If a lower dew point is required, a desiccant air dryer should be installed, and the air dew point must be processed to no higher than the required final nitrogen dew point. The EPSEA's nitrogen generators have all components, and the whole machine system rigorously tested, ensuring excellent performance during continuous operation, and making every bit of nitrogen a reliable guarantee for productivity.